Okay guys, I want to go ahead today and talk about any questions you might have with respect to the problem set you're working on. And then we're going to start to take a look a little bit further at the time value construction that you guys have, I know, already been exposed to, but we're going to take it a little further than you may have already thought about it. Then we're going to look at internal rate of return, net present value, modified internal rate of return, and then I'm going to introduce to you an Excel assignment that is due, I believe, next week. Fair enough? Okay. So questions that you might have with respect to using CAPM and WAC, the problem set. There's a question over here in the middle hat about G.
I have a question about like G later on, but not about CAPM.
Okay.
On problems J and K, I understand like that would like note plat times 1 minus G over ROIC is like a way to calculate a free cash flow, but I still don't understand why we're getting two so like drastically different numbers between G.
Got it. So we have G stated in this, and then we have some G that maybe should have been or could have been calculated to be stated, okay? And when we use the free cash flow form of the KV, based on the KVD construction of no plat times 1 minus G divided by ROIC, if we use this, we're putting in a number here that is our guess at what G is. And what was that G that was stated as? I don't still recall.
5%.
5%, okay. So remember from our discussion the other day, we actually talked about some of this, where we said we have a more traditional form of free cash flow, which is equal to no plat plus depreciation minus change in net working capital minus net capital spending. When we look at the change in net working capital, are we looking at the growth of net working capital? Yeah, it's either the growth or the shrinkage, right? Some percentage change if you think about it. We're using nominal dollars, but it can help us with, we can put together a percent change equation if we wanted to. When we're looking at net capital spending, what are we looking at the change in? In our fixed assets, not the total fixed assets, but the long-term fixed assets. So it's the other side, it's the other part of the asset part of the balance sheet. This is reflective of some of the assets on the balance sheet. The current assets interact with current liabilities. So we see some change there, and we see some change here. If we have our assets changing, and I'll say growing, at a rate, it might be reasonable to believe that our revenues or our revenue-like instruments could also be growing at a somewhat similar rate, assuming that our capital utility of our assets is constant. If I get a 15% off of all my assets when my assets grow, then that number grows well, or my end number grows well, right? But we've used 5%. Is this 5% indicative of those changes? It's not, which is why we get a different number. Because we're plugging in 5% here, Garrett, and that's just a guess. We used some actual changes here, so that's not a guess. All of that is simply why this is reserved for use in the terminal or continuing value of our valuation estimator, and why we use it in that one KVD form only, okay? Because now we're not thinking about the growth from a particular year, because this is for a particular year, right? A free cash flow. We're now forecasting a long-run growth, which may not have been the growth in that year. The growth in that year, I think, was much higher. Did you put it at 11 point something percent? Yeah. So if we put this in at 11 point something percent, I think 11.56%, then this free cash flow and that free cash flow are the same number, which would then suggest that the change inherent here was an 11.56% change in our asset base, and that we had a constant utility of our assets to revenues, and no plat, and et cetera. Does that make sense?
Yeah, the thing I get held up on is if we're taking that free cash flow and multiplying it by 1 plus the 5%, like how is that also not reflective of like a guess of the future?
Oh, it is reflective of a guess of the future. So you're saying, as we go from the explicit period, or the last year of our explicit forecast, we come up with a cash flow number, free cash flow number, right?
Yeah.
And then when we say that that free cash flow number is going to grow at 5%, or multiplying it by 1 plus the growth rate, so that we can get free cash flow for time 1, or the first year of our continuation period, when we're saying that, we are guessing that we're going to see that 5% growth. Why would we say 5% growth in perpetuity rather than 11.5% growth in perpetuity?
Is that unrealistic, like bigger than?
Yeah. Now, do we know that the 5% is right or not? We don't know. But is it more likely to be right than an 11.5%?
Yeah.
Sure it is. It's more watered down, which is a little bit disappointing. We played the game of CEO and compensation and moving from one regime to another as to why maybe that wouldn't exist. But common sense and observation tells us that it's probably more likely a fairly settled number. We don't have any examples of any firms having grown at double digits in perpetuity. Now, you might argue and say we don't have any examples of any firms growing at any rate in perpetuity, which is probably a fair statement, okay? But we're just way off outside of our bounds if we're trying to look at big numbers like that. And 11.5% is a big number. Any of you that have tried to grow a decent-sized firm, 11.5% is a pretty good number. Okay? If it's your startup in your first year, 11.5% is pathetic. Okay? But if you got a 20-year company running here, it's hard to crank out double-digit growth. What else? Zach?
So I kind of want to look at the formula for both of those two ways that we valued it. Because so with the first one where we use the growth rate of net working capital, we'll change net working capital minus net capital spending to find our growth of assets. What is the significance of that rate, and why are we still using the 1.05? We're still using the G of 5%, even though we already have technically a rate that we've calculated from that.
Okay, same thing. So, Zach, for what year was that 11.5% calculated?
Just for that first year, right?
Yeah, so that it is reflective of that year. We observed it, right?
Right.
In there for that year. But if we think that we're going to continue at that pace, well, good for you, man. Okay?
I guess, couldn't we just, I mean, I don't know how different they would, couldn't we have just used, are we just using it to get accuracy for the first year and then using the 5% just to estimate going forward? Or?
Yes, yes. So we use this free cash flow with these changes observed to give us an accurate free cash flow for that year. It's only for that year. We could calculate those growths through the investment rate and the ROIC, come up with a G, because I think that's what you did to get the 11.5%. And we find that that was indicative of an 11.5% growth in these measures for that year. But that's not necessarily something we think we can continue to achieve. And if you can, good for you. I hope that I am your new best friend. Because if you can do that forever, we'll both have our private islands in the Bahamas. If you're that generous with me. Okay? At least curious. Does that help? Okay. You got to parse out the time frame here. You got to remember why it's used, when it's used. And remember that this form of free cash flow, the KVD construction of it, is only used in the continuation term of the KVD formula. And if we're looking at a multiple based on the KVD formula, which you're going to learn later on, the multiples come into play in the continuation term. So it's not inconsistent. Please.
When we use the KVD formula, are we going to be calculating our own values of G, or is it going to be something?
Good question. It depends. So on the problem sets that you get, I think all but maybe it's the last one, you have information to help you know what the long run G should be. So if I say something like, we expect the firm is going to grow at approximately the same rate as expected changes in GDP for the nation, and that change is 2.5%. Or you'll have information, but there is one of them in which you get to decide what that number is. And you have to explain why you decided it, what it is, what you've decided it is. Please.
So I'm sure we'll get into this later on, but if I calculated a G from that current period that I thought was appropriate for continuation, would it be okay to plug it into the KVD formula?
Well, I think it's a good idea to plug it into the KVD formula just to see what happens. But remember that when you do that, all you're learning is the free cash flow for this period. So if you use the no plat from time one in the continuation, so the year after the end of the explicit period, and you try to mix this no plat with G from this year, you're doing an apple and an orange concept. Okay. Now maybe that's your aspiration. Maybe you're saying, we have seen this. You can even look at the G that comes from every year, right? Because you can do G year by year by using G equals investment rate times ROIC, because that's telling you about a particular year, right? You could look at that for every year that you're assessing. Cool. But it still doesn't mean that that's going to be your long run G. You might say, well, wait a minute, this company has achieved that G on average for each of the last 37 years. Why can't I use it in perpetuity? Because 37 years is a rounding error in perpetuity. And the dynamics of an infinite number are infinitesimally large, not small. Please.
We take G over ROIC to get growth rate as a measure of return on invested capital. Why do we use ROIC as opposed to?
Good for you. Can I state the question a little bit differently?
Yeah.
This ROIC, from what year does it come?
Previous year.
Yeah, previous year. So or a base year of some kind, right? Are we suggesting, when we use this ROIC that has come from a year prior to forever, are we suggesting that it is accurate for forever? Well, we're supposing it is if we're using it for forever, but maybe there's a flaw in that, or maybe as we're forecasting, we should be seeing that our return on invested capital is probably narrowing in on a smaller number. You'll see that later on when we start doing more forecasting. Good question.
Would it be better to take an average of, I mean, it's kind of the same thing, but let's say the company's been around for 30 years, take an average of your ROICs for those.
It might be. So you're talking about normalizing now, which again is what we're going to do when we talk about forecasting, because very often, if you take all of this based upon just one year, maybe it was a Shazam, whiz-bang, kick-butt year. And if you think you're going to repeat that year after year after year, you're up in the night. So maybe all of these measures that we use for forecasting should be averages of a multiple year period. Good.
And is there any other situation where we would use a different ratio as a measure of G, like return on ROA or return on equity or anything like that as a measure?
Good question again. So I think when you're trying to calculate what the firm's long-term G probably looks like, you are wise to look at ROA. You're wise to look at ROE. You're wise to look at ROIC. You may be wiser still to look at the IGR, internal growth rate, and the SGR, sustainable growth rate. Do you remember the equations for those? You used them very recently, right? Okay?
Oh, okay.
Yes, you very recently used them, so remember them or not, you're going to nod your heads like you did because you got them written down in front of you. You're wise to think about all of those things. If you're really using this, you're using it not for an academic exercise, right? You're looking at it to help you identify the value of something. And you're either trying to get that value from someone else and you're trying to build a case as to why they should pay that, or you're considering paying a value. and you tried to build a case as to what value you should pay. So you shouldn't just use a number, you should think about the universe of plausible numbers to try to think about what should this be. And maybe, and we'll look at this at the very end of the term together, maybe you should do your calculations based upon a range of numbers. You do one calculation based upon this level of G, one calculation based upon that level of G, another matrix based upon different levels of ROIC, another calculation based upon different levels of discount rate. And you maybe have a three-dimensional matrix of values, and maybe you even weight then the different outcomes to help you figure out what your value that you may hang your hat on should be. This gets relatively complex. We're looking at valuation methods and metrics here in this class, but we are going to scratch the surface. If you go on into Finance 409, you scratch it deeper still. If you go on into participate in the business valuation challenges or the university evaluation group, you gouge it pretty deeply, but not until you've scratched it a couple of times. One of the things that Oscar, who I think some of you guys know Oscar well, said not too long ago was that he really liked this way of looking at things because it looked like there was always more to learn about it. And there is. There just is. Anything else on that problem set? Yeah.
I'm kind of struggling to understand what the WAC minus G represents and why, because logically, I think, why wouldn't it be G minus WAC?
Yeah. No, I understand completely where you're at because I was there not a whole lot of years ago, okay? Think about this. What we're really looking at when we're using the WAC minus G, which is simply in helping us with our continuation term, what we're really looking at is some value that is equal to the sum of, I'll say, some free cash flows of periods I divided by 1 plus, I'll use W for WAC, to the T, where we have an infinite number of these terms and our FCF is changing at some constant rate of growth. So in this period, maybe we have FCF at time 1, and if our growth rate is, say, 2%, then the next one would be this FCF times 1.02. And the next one would be that FCF times 1.02 squared, 1.02 cubed, and so on to 1.02 infinite, right? That's what we're really looking at when we say that, and we don't put any bounds on this summation. Well, that is a pain in the neck, because we can't calculate an infinite series of values, because we're never done. But if you take this, knowing that this variable is growing at a constant rate of growth, and that this WAC is constant, it actually boils down to this equation. Okay? So don't mistake this relationship as being an important relationship in anything other than algebra. Okay? It's just algebra. As opposed to this relationship is critical. I wanted for a long time, Mikkel, to figure out the virtue of this relationship. Why was this such a critical relationship? Because if G is greater than WAC, we have a negative value, and it's almost impossible to overcome a negative perpetuity value. Okay? So what's the virtue of it? It is just an algebraic term. Now, as it turns out, it might be an algebraic term that hints at something else. And I think what it hints at, and this actually comes back to what you and I were talking about a few minutes ago, I think what it hints at is we may not have enough capital to grow at a rate that is greater than our cost of capital. We may not have enough capital on board. Now, it only hints at that, okay? You have to do a whole lot more with this to be able to see it expressly, but it does tend to tell us that. Okay? All right. So let's think about some of our time value construction. I'm going to put something up that you probably are going to get tired of if you're not already there. And that is our basic construction of value at time 0, which is now, it's when we might have to cut the check to pay for the asset, is equal to the present value of some discounted cash flow plus the present value of a continuing value. You're pretty familiar with that one now, aren't you? We've seen this, right? Nod or shake. Thank you. Okay. And the present value of our discounted cash flow is equal to the sum of our cash flows, and I'm just going to say our cash flow happens to be free cash flow in this case, divided by 1 plus a discount rate to the power of t. And a discount rate is generalized. WACC is a discount rate, hurdle rate is a discount rate, investment return is a discount rate, etc. Okay. When t is greater than 0, less than, I'm going to say n, whatever the number of years of our explicit period E is. Okay? And the continuing value in time 0, if we're using the free cash flow formula, is equal to the free cash flow in time 1. And time 1 is the first year after the explicit period. So that means that the last year of the explicit period is year 0 in continuation terms, divided by R minus G. If we're looking at this from the standpoint of the firm and its ownership, these R's should be WACC. If we're looking at it from the standpoint of an investor, a buyer, they're going to be whatever they think they really should have, their opportunity cost of capital. Because why invest in something if it doesn't give you at least your opportunity cost of capital, right? Okay. But again, R is simply a generalized term for discount rate, of which there are many. WACC is kind of like the king of them. Okay? And then the present value of the continuing value at time 0 is going to equal the continuing value at time 0 divided by 1 plus R to the t. And this t now is the number of years of the explicit period. So we had 5 years in our explicit period, that t is 5, because we're taking it back to time 0. Okay? Well, this then is the free cash flow model. So value using the free cash flow model is equal to the sum of free cash flows at times I divided by 1 plus, and I'll now call it WACC, to the t, plus free cash flow at time 1 divided by WACC minus G divided by 1 plus WACC to the t, in which t for the first equation is greater than 0 and less than, or greater than 0 and or equal to n. I said here less than n, it should be equal to n, excuse me. Okay, so that can be its range. I don't think my algebraic notation for range is accurate, by the way, but I hope you understand what I mean. I'm not that good a mathematician to remember the notations. Okay? So this might be years 1 through 5, and this might be a value at year 5 that I got using year 6's free cash flow. Because that's the year, that's time 1. In continuation terms, that's the year after the end of the explicit period. Okay? That's the free cash flow model. You will find that literally all of our financial models, valuation models, will follow the same pattern. Valuation using a particular model form, we use now the KVD form, is equal to the sum of the free cash flows at times I, divided by 1 plus WACC, to the t, where we have some known number of years for our explicit period, because this is all about the explicit period, that's the first term. Plus, no plat, times 1 minus G, divided by ROIC, divided by WACC minus G divided by 1 plus WACC to the T. The only difference between the free cash flow model and the key value driver model is what?
G.
No, that is included in the difference.
It's how we calculate the free cash flow.
It's how we calculate free cash flow in our continuation term. Free cash flow in our continuation term is being calculated as no plat times 1 minus G divided by ROIC, whereas free cash flow everywhere else on this board has been calculated as no plat plus depreciation minus change in net working capital minus net capital spending. So it's in how we have approached our free cash flow. Why do we use this form of free cash flow when we're thinking about something in perpetuity?
I guess you could use it if you have some kind of reliable measure of G that you would want as more average, I guess.
Okay? You're right. We're using it because of that pesky G and its problematic nature in our equations. If we used the same free cash flow here that we got from the traditional calculation for time 1, if we use the G that is inherent in that and put that G here, we would have the same number, right?
I was just gonna say,
Right.
it's because that free cash flow is evaluated at 1 year, whereas the key value driver formula is generalizing.
That's exactly right, Ryan. Because when we use free cash flow at time 1, as I'm doing in the upper equation for the free cash flow model, the free cash flow we're using for time 1 is indicative or representative of a growth rate because of how it was built. Remember, we're observing the change in net working capital and the change in net capital, or the net capital spending. But it's indicative of that observation for a year in which our growths may have been different. Our growths may have been different. And we had to think, what should that growth be? If this G is inherently observed in this number, then they're the same value. And if it's not, then they're not, and it almost never is. Why? Because the growth rate that we're assuming or observing by having forecasted year over year over year in our explicit period is almost certainly not the same kind of watered down growth rate that we're willing to hang our hats on in perpetuity. And we aren't willing to hang our hats on something really that heavy as we get further and further out on the limb. Because 1 extra ounce and the limb's going to break. And our valuation's garbage, right? Does that make sense? I know I'm probably really driving this point home too much. You've heard me say it probably a dozen times now. But only because it is that important. You can't suppose this great honkin' G that you're able to amass from your operations in the next several years, you can't assume that that will live with you in perpetuity. This is tantamount to the advice, understate revenues and overstate expenses. Why do we do that? Understate revenues, overstate expenses. Well, we do that because the alternative, when we're wrong, is disappointment. But if we understate revenues and overstate expenses and we're wrong, we're happy. None of us are bothered by being happy, unless those of you that are perverse and prefer to be in a bad mood all the time. And I spend enough time with students, there are a few of you all running around here that like that, right? Okay? So I'm going to tell you that these two equations, these two models have the exact same form. No difference whatsoever. But when I say that, what I mean is they both have the present value of a discounted cash flow and the present value of some continuing value. Their only difference is in how we've stated the continuing value, which probably then gives you a hint that almost all the other models we'll look at, the only difference between them is in how we're stating or estimating the continuation term. Fair enough? What questions would you have about that?
So, this is, I guess, kind of a usage question when
Okay.
it comes to these models, right? Now, I remember in the motoring video, he was saying you only want to go, it's like 3 years, or whatever it was, for.
Yeah, he doesn't like to use more than 3. In fact, he prefers to use as few as is necessary to get to a number.
So, if you're someone who's doing these valuations, are you calculating them quarterly, annually, or what are the implications of using these models?
Good question. So I'm talking to you, and I will throughout the term, about numbers that are pretty much annual values, okay? But could you use quarterly values? Could you use that quarter's free cash flow?
Yeah.
Sure. What else would you have to do to the equation then to get a consistent outcome, consistent answer?
If you haven't like calculated your depreciation, or if your taxes, they're not done yet, or.
Well, let's assume that you have an estimate, since we're estimating anyway, right?
Right.
Because future is all estimating. Let's assume that you've done a quarterly estimate, and that you're going to be as right as assuming an annual estimate, just times 4, right? What else has to change? Think of the bond value equation. When you use payments that are received less than annually, what else must be adjusted to meet that?
You have to divide the value by 4 for whatever time period you're using, because.
Well, not so much the value, Zach, because the value.
The
did you think-
percent. that-
Yeah, you gotta divide your discount rate by the number of periods per year, 4 in this case. You have to multiply your T, or your years, by the number, so that you get the equivalent of an annual number. Why are we looking at annualized numbers?
Well, to know at the first place if you should purchase or not.
Well, there's that, but I use annualized numbers because you use annualized numbers, because the guy at the car dealership uses annualized numbers, because the guy at the Fed uses an annualized number. We tend to think about and talk about annualized numbers. We don't tend to think about monthly interest rates. In fact, my guess is if you have a mortgage, you know immediately what's the interest rate on your mortgage. You might say, well, it's 3 7/8%. If I said, what's the monthly interest rate on your mortgage? We don't think like that, so that's why. So, and everything we do here in this class will pretty much be in annual terms, in terms of using these values and valuation, but you could break it down more finitely than that. I'm just not sure why you would do that to yourself.
Is there any benefit to it? Is there any reason why someone would do that?
The only reason I can think of is if you were compounding a discount rate. But we tend not to compound discount rates, because discount rates are a bit ethereal anyway, right? They're numbers we came up with. So that's the only reason I can think you might want to do that. It's probably not a great idea. If nothing else, you're just burning up brain cells without needing necessity. Okay? All right, so you guys have, I'm sure in your possession, some quick sheets to help you understand time value of money and valuation models. I've not given you any in this class yet, have I? I didn't think so. Okay. Kira, and we're just going to let these pass around. Just start there, and back, and then over, and then back. You take that, and then I'm going to burden you to take that. Okay? And those of you that had me in Business 101, you've already seen some of these. One of these is just a quick sheet or a crib sheet for time value of money calculations. Super simple. And the next one talks about some of the different forms of the valuation models that we will use. Okay? Which are, understandably, just time value construction. I'm not going to spend a lot of time on this today. In fact, not much more than that. The one you'll see that's two-sided, some of you are saying, well, this says the same exact thing on each side of the page. It does, it just says it differently, and I present them to you in both ways because I found that some of you connect to them when I present it one way better than you connect to it when it's presented the other way. In this class, we'll spend our time focused on the utility of the free cash flow model, the key value driver model, and the forward market multiple model, which is only different from these in that I use a multiple to calculate a continuing value rather than one of these time value functions. Yeah?
Throughout the semester, are you saying kind of like these will be the main models that we'll be doing work
Yes. In fact, this is more than we'll deal with.
in?
Okay? And And I have another item I'll give to you on Wednesday as well, that is just kind of another repetition. In fact, what I'll give you on Wednesday, most of you have been in my office, and you see that big poster on my wall. I've got a PDF of that. It'll be helpful for you sometimes, especially when you're thinking about your essays and such, and getting ready for exams. Okay, you're doing problem sets and pretty much everything else. Yeah.
Are we expected to learn all the formulas by heart, or are we going to be able to bring it?
That's a great question. You'd have to, and I don't immediately recall the answer with respect to the exam. I think, but you can't hold me to this, that I allow you to use one side of a 3x5 index card for notes, if I remember correctly. But the reality is, everything I have on the board here is one equation. It's that. All you're having to remember is what present value of the discounted cash flow means, and then you have to think about the different forms of continuing value, of which there's only going to be 3 for you to focus to. Now you've got FCF and ROIC and no plat and all that other stuff too, but you can fit all this and a lot more on one side of the 3x5 index card. There is far more commonality in these equational forms than you immediately recognize, which is part of why I'm showing it to you the way I do on this. Okay? There's a couple of forms on here, the economic profit model and the adjusted present value model. The economic profit model, I'm not sure that we're going to talk about it all unless we get through some things faster than I expect us to, and even then it'll be just a light discussion about it. I'm hoping to get to talking about the adjusted present value model, okay, because it has some relevance. And it looks like the ugliest one on here, and it's actually the free cash flow model times 2. That's all it is. But we think about 2 forms of cash flow. Okay? All right. So let's switch gears now. I want to talk about time value of money from an internal rate of return and a net present value perspective. To do so, you got to bring up the computer. Yes.
So, but over here, where he only wants to use 3 years of maximum, is that in the calculation? What if if you just, particular 3 years, what if those 3 years yielded unusually high growth?
Good question. So Demoter likes to just use 3 years or less, right? And what if the periods he's using represent unusually high level of growth? Well, you're then going to have the continuation term, right? There's always a continuation term of some kind. And the continuation term, if he's allowed it to have a reasonable G, since it is so long, infinite number of years, it will overcome the unrealistic nature of his few years. Now, his few years may not have been unrealistic for those years. They're just unrealistic for forever. So let's think about this while some of this comes up. Is it possible to come up with a explicit period in which you have more than one rate of growth of your cash flow variable during the explicit period? Sure. You could do that, couldn't you? You could say in the first year we're going to grow 35%, in the second year we're going to grow 24%, and then 37, and 18, and 19, and 20, and whatever it is. And the reality is you could do that, or you could say I'm going to grow for all 5 of those, or 3 of those at 7%, and then another 2 at 8%, and then I'm going to water down to 3%. You can do whatever you want with this. But recognize that when you do that, you're simply extending the explicit period and thinking about the growth that you are expecting. When we get to forecasting, you're going to see that we will forecast each and every year of the explicit period. That lets us not worry about what the rate of growth is during that year. We won't assess our free cash flow values by some rate of growth during those years. We will assess them by having observed them based upon the growth inherent in our different forecasts. And I might think my company's going to grow at 8% this year and 9% next year, and then I'm going to be concerned about maybe an economic recession for a couple of years, and then we're going to go back to, and your growth values during your explicit period probably will not be equal to each other, right? They're almost certainly going to be different rates of growth during those years. So give me a second to do this. Well, I honestly do know my password.
So hard to watch. Honestly, I watched this thing.
By the way, tonight, for those of you that are at all interested, there is a discussion taking place sponsored by the Center for Innovative Cultures. I can't remember immediately off the top of my head the name of the gentleman, but it's about the second wave of the digital revolution. And I've read some of his material. His name's Ron something, if I remember correctly. It's really very interesting. The second wave of the digital revolution.
Where and when?
It'll be in the auditorium at 6 o'clock.
Tonight?
Yeah, tonight. There's a little reception preceding it in the atrium. And then tomorrow in the atrium at 4 o'clock with the finance group. Okay. You remember internal rate of return? What's internal rate of return telling us?
What rate your capital is growing on a yearly basis?
Okay, yes.
Not accounting for where else we can invest it.
Well, as it turns out, it does kind of account for where else we can invest it. But it might make an erroneous assumption. Okay. And I'll have to apologize. I have 2 classes right now, and you're almost at the exact same place. And so I sometimes forget what I have gone over with you versus the other class. And it's an MBA class, and very quickly you diverge. Have we gone through and done net present value and internal rate of return equations on our calculator yet? Okay, I didn't think so. So we're going to do a little bit of that. In fact, I'll even remember to bring the lights back up so we can do it. So let's assume for a minute, we have done some calculations with our calculator, right? Using the top line function?
We haven't done it.
Not yet. But you guys did so in Finance 300 and Business 101. Okay, good. All right. So let's assume for a minute that we want to calculate the present, ooh, that's a terrible pen. The present value, is that any better? It's not, is it? The present value of an asset in which we believe that it's going to give us cash flows of $200 for each of 5 years, 1 through 5. Okay? And at the end, it's going to give us a value of $1,000. And we have a discount rate equal to 10%. Okay? And we want the present value. Well, we know we're going to calculate present value. We have payment. We have time. We have rate. We have future value. Right? That's what's going to give us the end of this 5 years. We'll call that a future value. We know 4 of 5 variables in the time value equation. We can calculate the 5th, right? And when we calculate the 5th using your calculator, we first make sure that we have set the right number of periods per year. Who remembers how to do that?
Number 10.
Pardon?
5 and 10.
It's not, but you're close. We need to set the periods per year, and that doesn't change until you set it again. Okay, even if you clear all, the periods per year remain set. You type the number of periods you want. In this case, we're going to do an annual calculation. So 1 red PYR. PYR is on the top row, second from the right. It's in red underneath that PMT. So one red PYR, and that's going to give us 1 period per year. Your calculator must be told how many periods a year. If we were doing a monthly payment of some kind, it would be 12. Semi-annual would be 2, right? Okay. So we're at 1 period per year, and when we have a constant cash flow, because this cash flow is not changing, then we can use simply the top line function. But you can only do that when you have a constant cash flow, okay? So in this case, we're going to say 200 PMT, that's our payment. I'm putting it as a positive value because it's a payment. I'm going to get that income, right? And the convention I use is I use a positive value when I'm getting it and a negative value when I have to pay it, because I don't like letting go of it, okay? And I'm going to use 5N for the periods of number of years. I'm using 10, not 0.10, but 10% I divided by YR. And I'm using 1,000 future value, because I'm assuming that this will give me a $1,000 payout of some kind at the end of the 5th year. Maybe that's a salvage value. Maybe it's a continuing value. Maybe I've agreed to sell it to somebody in 5 years for $1,000, some ending value. And with those in, I've given it future value, payment, I divided by YR and N. I can press PV, and it tells me that it is $1,379.08. But it tells it to me as a negative. How come?
Because that's your initial investment, you have to pay it.
Right, Sherry, I'd have to pay that, so it leaves me in order to get these. Okay? So the top line function I can use that way. But rarely am I going to have a constant cash flow in one of the businesses we're adjudicating, right? So let's look at it differently. I'm going to follow my eraser. We're going to use the cash flow function, but we're still going to use $200 a year constant for the first time, and then we're going to change it. So I've got in years 0, 1, 2, 3, 4, 5. I have $200 in cash flow for each of these years. Plus I get $1,000 at the end. That was my future value. It was a salvage value, continuing value. We came up with it somehow. Okay? I'm still going to use my same 10%. And I'm going to use my same periods per year. I'm going to note for a second what the present value was, 1379.08. So now I'll clear by just a red C, and I want to put in my cash flows, my time, my rate, and my future value, all of them. But I'm going to put them in using different keys. I'm going to use the CFJ key, which is in the middle of the 3rd row down. So I'll start this by saying 200, excuse me. I'm going to start it by saying 0. Because at time 0, what is this going to give you? 0. It doesn't give you anything until after you've had it for a while, right? So, and this calculator starts at time 0. So 0 CFJ, 200 CFJ. And I can continue now to simply touch the CFJ button, since my cash flow is not changing, for time 2, 3, 4, whatever's on the display, it's accepting as your cash flow. But I'm not going to put it in for time 5. Why?
Because you get $1,000 back.
That's exactly right. So I'm going to put in 1,200 for time 5, right? So 1,200 CFJ. In doing so, I've given it the cash flows, and I've simultaneously given it the years. Because every time I press the button, it told it, think about one more year. And I've given it my future value. If I didn't give it a number here, if I just left that blank, so I just left it at $200 in year 5, and nothing else, I would be saying there is no value beyond that. So it's 0, and we don't have to tell it 0 because it knows 0 when you clear it, right? Okay. I do have to give it the rate, so 10, again it's the I divided by YR button. And now I'm going to calculate a net present value. You can't use the present value key when you use the CFJ key you must use the net present value key. And the net present value key is the second row, second button from the right. It's activated by the red key, so red NPV. And magically it gives us the exact same number.
Why is it not negative?
Good question. I don't know why. It uses, I just don't. It uses an input-output structure when you're using the top line functions, and it doesn't use an input-output structure when you're using the CF functions. Please.
So I see the thought process by just doing 1200 for 5, but how do we not know that's like a, I don't know the right word, how do we know that's not just a cash flow, like that one's happened to be a higher one and then there's a different future value?
Well, it could have been that, but I'm telling you the story that you have is this gives you $200 cash flow for each of 5 years, and at the end of the 5th year, you're salvaging it out, selling it out, something at a target price of $1,000.
Okay.
So that's your story. So your story informs your numbers.
Okay, so you're
Okay.
saying if like the 5th year is like $700, you would just find the future value and tack it on top of that 700?
Well, or the 5th year was $700,
Okay,
and at the end of the 5th year, we close it down, and there's nothing left.
so just keep it at
Well,
700.
but that's probably not realistic. There's probably some salvage value of something, right?
For
Even if we just sell off the crappy metal desk for $5 to the junk dealer.
Okay,
So there's probably something. But we're rarely going to use a salvage value. We're going to calculate continuing values almost always.
okay.
Okay? Okay, well, so all we did was prove to ourselves that this is the same calculation. Okay? Or comes up with the same number. Let's change our cash flows now. Well, by the way, before doing that, I want to calculate my internal rate of return. So how do I do it, Zach?
Secondary IRR, or red IRR.
So go ahead and do that. Press red, and then the IRR button is to the left of the NPV button, so second row down, middle button.
No
So
solution?
red, IRR.
No solution?
How come?
Which is your-
You don't have the present value in year 0.
And we didn't give a value in year 0, we didn't give a cost. So we have nothing we're getting a return on. We haven't told that there's any investment we're getting our return on. Zach's exactly right. We're going to do that next. Okay? So let's run this again. Let's go ahead, and in fact I want to run it again, but we're going to run it on a different set of numbers. Okay? Just so we can practice. So we've got 200, 300, 400, 500, 600, and let's say that we now have a continuing value. And we want to calculate our continuing value as 700, because we're supposing some cash flow in time 6 at 700, but that's the first year of our continuation period. It's not our explicit period. So 700 for cash flow at time 1 divided by R, 0.1 minus, let's say, 2% G. So I have a R and G equals 2%. So I've created a continuation term now.
Is that 2 given?
It would have to be, and that's, sorry, 0.02. Or you would have had to have a reason to think of it, okay? I try not to leave you guys in the dark on these. When there's a problem set or an exam, I am either expressly telling you the numbers, or I'm giving you information from which you should be able to fairly readily identify the number, or I'm giving you the latitude to assume the number and tell me why you assumed it was what it was. Okay? Well, in this case, 700 divided by 0.08 is $8,750. And I'm saying that if this company has these cash flows and expects this cash flow in year 6, and that those cash flows are now going to grow at 2% beyond that, this is our continuing value. What does the continuing value embody? It embodies all the future cash flows beyond this point in time. Not including this point in time, beyond this point in time, year 5, right? It embodies all of them in a single number. We want to find a net present value and an internal rate of return. And to do that, we can't have an infinite series of values because I can't put an infinite series of cash flows in the calculator, can I? I have to have some explicit series, and then I can have to have one number that embodies all the rest of forever. And that's what this number is when you use this equational form, isn't it? This is D1 divided by R minus G. FCF1 divided by WAC minus G. It's that number. Okay? So now, we're going to have to think about adding this number to this cash flow. Because this, in effect, is a future value, isn't it? And it's a future value as of this moment in time, year 5. Because it was value at time 0 is equal to some cash flow at time 1. If year 6 in this case is the first year of the continuing period, year 5 is the last year of the explicit, or year 0 of the continuation, and that's where it has to be added to. All right? So let's run that. And we'll keep our 10%. So we're still at 1 period a year. So we're 0 is our 0 times 0, and then 200 CFJ1, 300 CFJ2, 400 CFJ3, 500 CFJ4, and now I believe that this is 9,350. 9,350 CFJ5. So we've told it every one of the years. 10 I divided by Y1. And then we're going to solve for net present value and red NPV, or 6,877 and 40 is what I got. You guys get the same number?
Yep.
Okay. Notice that we use the net present value function to find this, but is this a net present value? It's not, is it? A net present value is going to be where we've netted our costs against our benefits. We haven't netted out a cost, have we? So really, it's just the same thing as a present value. So you can use the NPV function to find a present value when you have non-constant cash flows. You must have a constant R, regardless. There is no ability to change R's in using the time value functions here. But you can have a non-constant cash flow, and that will become very handy for you. All right? So remember, that gave us a net present value of 6,877. If we tried to find the internal rate of return, we'd find no solution again because we have not given it any kind of cost. So let's do that now. Let's give it a cost. Let's assume for a moment that I paid exactly what it was worth based on this calculation. Okay? So we're going to rerun our numbers. Clear it? And we'll say 6,877.40, but we need to turn that into a negative. How do I turn it into a negative on this calculator? Yep, plus or minus, which is right above the blue key. It's a toggle switch. Okay? So negative CFJ, it accepted it for time 0. So I'm inferring that that's what we're paying to get this future stream of income. So I'm paying 6,877 to get 200, 300, 400, 500, and 9,350. So let's put those cash flows in now. So 200 CFJ, 300 CFJ, 400 CFJ, 500 CFJ, 9,350 CFJ, 10 I divided by Y. But now we're going to calculate a net present value. Any guesses, without this having done the work for you, as to what the net present value will be? 0. Why?
That's how much you need.
Because the present value of these cash flows in years 1 through 5, inclusive of our continuation, was 6,877.4. Well, that's the present value of the benefits. If the present value of the cost is the same number, we get 0. Let's see if we can prove that to ourselves. What would our internal rate of return be if we had a net present value of 0?
0 or negative.
What do you think?
Based on the R.
I think it's 10%.
'Cause the R.
I think it's 10%. Let's see if it is. So red IRR. It's 10%. How did I know that? Well, the discount rate that we imputed was 10%. So in order for this to have rung true as 0 in the net present value, then we would have gotten exactly what we expected. Now let's test the net present value. Red NPV is not exactly 0, is it?
We rounded to 40.
Yeah, but it may as well be. Mine is negative 0.000000000048. I think that's close enough. Is that 0?
Yeah.
It is to me. Okay. If you want to cheat me out of that 48/1 millionths of a penny, go knock yourself out. Okay? I'll never notice it, nor will you. So when the net present value is 0, it means that our internal rate of return is our discount rate. We got exactly what we expected. If the net present value is greater than 0, what does that mean?
Your internal rate of return was higher.
Exactly, Kira. We got more than we expected. And inversely, if the net present value is less than 0, negative, then we got something less than we expected. Okay? So let's run these numbers again, but this time, I want to run it with a different cost. Yes, I calculated when I was trying to assess the value of this to me, based upon my discount rate, these cash flows, in this time frame, I calculated it was worth $6,877. But you know, I always like more, right? I don't like less, I always like more. So let's assume for a minute that I was good enough at my negotiation that I was able to get this investment for $6,000. Okay? So now let's run the numbers. Red clear. I'm going to say 6,000 negative CFJ 200, CFJ 300, CFJ 400, CFJ 500, CFJ 9,350, CFJ 10 I divided by Y. What do you think the net present value is going to be?
Probably slightly
Would it
higher.
be 877?
Exactly, Garrett, because this is the present value of the benefits, and you were laughing for a minute. I thought I called him Ryan for a second. I had to check my brain. But I called him Garrett. So if this is the present value of the benefits, and 6,000 is the present value of the costs, the net present value is going to be a positive $877.40. So we know that, right? So that means there's another way of calculating net present value. If you know the present value of the benefits from assessing the cash flow and estimating its present value, minus what you're willing to pay for it is your net present value. So let's see if we're right. Red NPV. Darn, we're right. We're good. Now, we also know that the internal rate of return is greater than 10%, don't we? We know that it's $877.40 greater than 10%. Do we know what the interest rate is on that? What its IRR is? We don't, unless you're better at this than I am, okay? So red IRR.
13.2.
Very good. 13.2863%. That's my IRR. Surprising? No, it's a little bit more than 10%. But here's a problem with the internal rate of return calculation. The internal rate of return calculation, which is what the vast majority of financiers use, assumes that cash flows can be reinvested at that rate, that amalgamated IRR. What if I'd been just so good as to have bought this asset for $1,000? Then I would have had a $5,877 net present value, and my IRR would have been 60%, something, I mean big, right? We might argue that if my opportunity cost of money, my discount rate is 10%, that it's not way outside of expectation to have been able to invest it at 13%, right? That's a little bit more, but it's not ridiculous. But if I have an IRR of 60%, is it realistic when my opportunity cost of money is 10%? Is it realistic that I can reliably reinvest at 60%? No, no, it's just not. The internal rate of return calculation that virtually all estimators, Excel, this calculator, the TI calculator, all of them, finance books, every one of them, supposes that these cash flows are being reinvested at this rate that is being calculated. Is there a singular equation to calculate that rate? There's not. There's not. And it's an extrapolation. So your calculator is making a guess, and it's comparing that, calculating, making a guess, comparing, and honing in on it. And fortunately, you don't have to do that. Excel does the same thing. I won't give you, because there isn't a singular equation for IRR, I would never expect you to calculate IRR by hand. You will always be able to use this or Excel, okay? But it's a flawed measure. It's not accurate. There is an accurate measure. It's called modified internal rate of return. And there is an equation for it, and you've got it in the notes online and such. I'm not going to hold you accountable for the equation in terms of manually calculating it, but you'll be able to calculate it with Excel. I don't know how to calculate it with this calculator. I don't know that you can calculate it with this calculator. It doesn't have a mirror, MIRR, modified internal rate of return function, but Excel has one. I'll show it to you in a few minutes. And when you use that, what's happening is the cash flows are being reinvested at the discount rate. Because if that is really your opportunity cost of money, that's the only rate at which you should reasonably be able to expect to reinvest them. And so it typically gives an internal rate of return, or a modified internal rate of return, something less than the IRR, and it is more accurate. But just because it's more accurate, Mason can tell you almost no financiers use it. I don't know why that is. I use it. I'm a geek. But I only use it when I'm doing things for myself. When I'm communicating to somebody else, I always use IRR, because other people talk in IRR terms, not modified internal rate of return. Okay? So IRR is a flawed measure because it supposes that cash flows are being able to be reinvested at this amalgamated rate that it's creating, whereas modified internal rate of return supposes the cash flows are being reinvested at the discount rate. And that makes more sense. There's a better litmus test for that, right? Okay. Either way, if the net present value is greater than 0, MIRR and IRR are greater than the discount rate. What if instead I paid $7,000 for this? We don't have to run the numbers. We can tell as much as I need to know just by looking at it. What do we now know about my net present value?
Negative 123.
Yeah, negative $122.60, right? $123. Good enough. Would I choose to invest in this if I had to pay $7,000? My discount rate's 10%.
No.
No. Technically no, right? Because I'm saying I'm not even going to be able to get 10% if this is my opportunity cost of money, which means I can get it elsewhere just as readily. Then why would I settle for something less than 10%? I don't know the exact rate. I can find it out. We now know how to do that. I know it's going to be a negative $123 in interest over this period of time, but I wouldn't do it. But what if I did do it? Let me put it differently to you. What if you have been working for Xerox and then L3 Communications for 18 years of your career? You've been frugal. You put away several $100,000. You are able to borrow another $5 million, and you come across a business that you want to buy. And it's going to cost you all of that to buy it. But, so $5,700,000. But you calculated a present value of $5,200,000. It's going to cost you $5,700,000. Well, if you were serious about your discount rate, if it was your litmus test, your decision criteria, you would not buy the business, right? It's going to cost you more than you estimated it's worth. But what if you did go ahead and buy it? What are you signaling? Zach?
That you could make changes that would possibly increase cash flows if you can have some kind of influence or.
Okay. So you believe there might be, and I'm going to start to use some terms that we'll use again with when we do forecasting, there might be a best owner premium. You think you can, if you own this business, get a better cash flow so that you would have a better present value. And your original assessment of present value was based upon the company's forecasts. Okay, I think that's fair. What else might you have been signaling?
That your R is not equal to whatever you set it to, but it's actually less.
Yeah, you might be saying, hey, you know what? Maybe I'd be willing to take 9%. I don't know if that's the right number for this, but maybe I'd be willing to take a slightly lesser percentage. Under what circumstances would that be true?
So you want to buy a really, really nice Italian pizza shop, and it's your dream, right? You might be willing to reduce your R.
It's your dream. So there's some utility that you expect to get from owning this other than just cash flow, huh? Do you suppose business owners receive some utility other than cash flow?
Yeah.
Yeah.
Yeah. If you've spent the last 17 years working for Xerox and L3, and now, so you've been working for the man, right? And now you're going out on your own. You're going to be the president and CEO of this company. That gives you some personal satisfier and utility. Now, what you don't realize, that means you are now the chief cook, bottle washer, janitor, and the whole 9 yards. But that's okay. You'll learn those things, right? And maybe you do know that. It means you're willing to accept a lesser R because of what other utility it gives you. So be willing to think about those kinds of things, okay? Any questions about any of this construction? Please, Karen.
When you said that IRR is a flawed value because it assumes that you can reinvest, is that internally or externally? Like reinvest where?
Well, it assumes you can reinvest somewhere for this big rate. And I don't know that it's terribly unrealistic when 13% is the IRR and 10% is the discount rate. But if you come up with a 20, 30, 60% internal rate of return, if you believe your opportunity cost of money is 10%, you're asking the right question. Where do I think I can get 60% return? So it's just assuming you can invest it somewhere at that. It's not suggesting where, and you and I would ask the question, where do I think I can get 60% credibly? I can't, and that's the flaw in the measure. Okay? Doesn't mean you shouldn't use the measure. You should use it for comparative purposes. If I compare one IRR to another, I'm comparing apples to apples, right? They both have the flaw. Would I compare IRR to MIRR, modified internal rate of return? I ought not, because they're apples and oranges, right? Okay. So I want to show you now a multi-columnar structure in Excel for doing this. The spreadsheet I'm about to show you is linked in the Excel templates part of Canvas as it goes out to a different website that I have. And you don't need to go there, just kind of follow along on the screen at the moment. I'm going to show you some interesting elements with respect to decision criteria. Okay. We're making a couple of assumptions here. We're going to focus on this part of the screen at the moment. Are you guys able to read these cash flows? You see them back there, Mason? Okay, good. Thank you. So we're assuming in this case that we have that we're looking at an asset that has a $40,000 cash flow in period 0. So the base year. We don't own it yet, okay? So that's not a future cash flow. We're not going to base our investment on that. We're only going to use that number to help us forecast future cash flows. And we believe that those future cash flows are going to grow at 13% for years 1 through 4. So we're saying that we've got a 4-year explicit period. I've put the $40,000 here, but only to help me calculate these at the moment. Okay? It's not really a cash flow at time 0, is it? I just put it there. Okay? So in this cell, you would see a formula that says the prior cell of $40,000 times 1 plus 0.13. And then the next one says 45,200 times 1 plus 0.13. But it doesn't say that in those terms. It uses a model construction. So I don't keep putting down numbers. I just have the cell in the formula in the cell relate to other numbers that I have to put down. Okay? In fact, if I wanted to do this more accurately, I can change it very quickly. I'm going to say here that's equal to, what is that, E5. And now I can get rid of that. So I've created a more realistic looking model, okay? So I've created my cash flows in years 1 through 4 in this case, where I believe I have a 13% growth. And then in year 5, or the first year of my continuation period, I believe I'm growing at 5%. So you're going to see here a formula that simply takes the value from the row before it and expands that at 5%. So multiplies by 1.05 or 1 plus whatever's in that long run growth rate cell. In the next column, I have the present value of these cash flows. So you'll see in that cell that I take the cash flow and then I divide it by 1 plus my discount rate to the T. And every time I'm not putting the T in here, I'm just telling it, come over here and find the T. So it's a model. So I can easily change any of my inputs up here and it's going to change the whole thing. Okay? That's a model. You're not continuing to program and you don't put any real numbers in the cells. You put formulas. Read line. Well, okay. And then here in the final column, I have a running total of my present values of my cash flows. That's why it's the sum of the present value of the cash flows. So in the first period, I had nothing before it, so it's the same number. In the second period, it's this plus this equals this. Plus this equals this, plus this equals this, all the way to the end of my explicit period. So now I have the present value of the discounted cash flow during the explicit period. And I could have done that with a singular equation in Excel, but I'm doing it in a multi-columnar format for a particular reason. And that reason is exclusively to help you see what's happening. Okay? I'll show you later on what that equation, where that formula would be, where Excel would just do it for you. But I'd like you to see this. So on some of the assignments, I'm going to ask you to use a multi-columnar form to calculate some of this. And you'll see that I give you the solutions in the multi-columnar form. Not because it's the most efficient form to use, but because it lets you see what's going on while you're getting used to this kind of thing. Okay? All right. Well, we know that the value of this asset spinning off these cash flows in these years isn't the present value of the discounted cash flow, don't we? What am I missing? I'm missing the present value of the continuing value, aren't I? Because these cash flows aren't the end of the story unless we, for some reason, have said that they are and have a reason to believe they are. So I'm going to come down here real quick. And here, in this cell, I've simply repeated the present value of the discounted cash flow, which was that summation column's final number. And in the next cell, I have my continuing value, which you would expect to be the cash flow in time 1 divided by WACC minus G. So it's the cash flow in time 1 divided by R minus G. Cash flow in time 1 divided by R minus G. So it gives me a continuing value. In the next cell, I have the present value of the continuing value. So it picks up the continuing value and divides it by 1 plus the discount rate, which was up in cell E4, which is off the screen, to the power of T, T being the number of the last year of the explicit period. And the next one, I simply add those two together to give me a value. That's a present value. That's exactly the same thing we did on the calculator. but we're doing it in Excel. Okay? Cool. Gave me a present value. I'm suggesting, remember that number, 544,699. I'm suggesting that this investment has a proposed cost of $460,000. So immediately, what do we know about its net present value?
Positive.
Positive, and how much is it?
A little less than 100 grand.
Yeah, it's 94,000 something, a little less than $100,000. Because Garrett took the present value of 544 minus the proposed cost. Present value of the cash flows minus the present value of the investment is the net present value. Okay? What do we know, Garrett, about the internal rate of return?
Positive.
Yes, we know something more that's a little richer than that. What do we know, Bobby? Cole?
It's going to be above the 15%.
Exactly. When the net present value is positive, the internal rate of return or the modified internal rate of return is greater than the discount rate. When net present value is equal to 0, those rates is exactly the discount rate. And by the way, when the net present value is 0, modified internal rate of return and internal rate of return are the same number. Because remember, internal rate of return is assuming we're reinvesting at this amalgamated rate, which happens to be the discount rate. So the same number in this case. Okay? All right. So I now want to think about calculating, I'm going to come over here now. I want to think about calculating my net present value, and I'm doing it two different ways, and I'm seeing my internal rate of return and my modified internal rate of return. I put together another column to do this, though. And notice that this value in time 4 is not the same as this value in time 4. 750,000 versus 65,000. Very different numbers. What have I done to increase the number here? What did I do? Think about how we used this in the calculator.
Added the continuing value.
I added the continuing value. And remember the continuing value was 684,798. So I added that to 68,479 and it gave me 750,000. Why did I have to do that? Why did we have to do it when we worked with our calculator? Why couldn't we just pick up an infinite series of values?
Because
Right?
otherwise, doesn't it assume the next year value will be 0? Because the calculator
The
can't-
next value is 0. And at some point, even if we give it 17 million inputs for every one of 17 million years, it thinks the next one is 0. And we know there's a next year that's not 0. So we have to use this amalgamation from the continuing value form, and then we put that number as an additive to the cash flow that we believe we're going to get in that same year. Okay?
Rick,
Well, yes.
with the continued value, are we going to be solving for that almost every time, or is that usually given? Because in the past I've noticed that's usually a given number.
Yes, and you will virtually always solve for it.
Okay.
But you'll know how.
Yeah, for sure.
you're
I'm
not.
just, I have,
Yeah,
okay.
but you'll almost always solve for it.
Okay.
It tends to be one of the easiest parts of what we solve by. Okay? All right. So now let's look at how we put together the net present value. You know Excel, and Excel's pretty bright, right? It does all kinds of cool functions. Excel doesn't understand something that you know and that you know intuitively. Excel does not understand time 0. You would think that I could go in here and say equals NPV, which is the net present value function. And when you do that, it wants to know the rate, that's the discount rate, and then it wants to know the string of values. And you might say, okay, so we're going to let that be equal to 15%, and then we're going to let it be equal to the cash flows.
You threw out the comma.
Oh, thank you. That was E4, I believe. Comma. And now we're going to pick up the cash flows. Okay? We're going to think this, and we give it a number, and that number is 73,651.67. But I'm telling you it's 84,699.42. How do I know that? Because the present value of my benefits versus the present value of my cost gave me this number. Okay? So I know that that 73,000 number is wrong, but why is it wrong? Because Excel doesn't understand time zero. It doesn't grasp the concept of time zero. Okay? So we have to kind of fudge this a little bit. So here I've given you the equation just as the present value minus the cost. Okay? And then in the next cell, I use an alternative equation. I use the Excel function, in which case I'm saying net present value, open parentheses, is E4, that's what the discount rate was. And then I only pick up years 1 through 4 because Excel doesn't understand times 0. I close the parenthesis, and then I'm adding my proposed cost at time 0. Okay? I'm adding a negative value, which is the same thing as it having taken it at time 0, right? Because anything to the power of 0 is 1, so it would be that number divided by 1, which is that number. You have to do that. One of the spreadsheets, one of the templates I have in here is the other decision criteria template, links you to an article that talks about Excel's flaw. But I don't know that it's a flaw. I think it's Excel's architecture, just is a little bit different. Some people think it's a flaw, and here's why. You would suppose if in calculating the net present value, if Excel doesn't understand time 0, then Excel wouldn't understand time 0 in calculating internal rate of return either, right? But what's the function for internal rate of return in Excel? It is exactly what you would expect it to be. Internal rate of return, open parenthesis, pick up the entire column, close the parenthesis. We're not giving it a rate because it's calculating the rate, right? But we've given it time 0, and I'll be darned, it gives you the right number. It gives you the exact same number your calculator was using. So either they're both wrong, or Excel's methodology for IRR comprehends time 0, and its methodology for net present value does not. And that's what the article talks about. Okay? Modified internal rate of return, very simple again. Exactly what you would expect it to be. Let me kind of come over, open something. So M equals MIRR. Open it up. But now it wants to be told the range of values, which we'll give it. But it has two different rates it wants to think about. A finance rate and a reinvestment rate. The finance rate is your discount rate. Okay? Whenever I do this, my reinvestment rate is also the discount rate. This simply gives you the latitude that if you believe that you can reinvest at a rate different than the discount rate, you can input that. I don't make that assumption, otherwise the 10% or whatever wouldn't be my discount rate. For me, my finance rate, if it really is my discount rate, is also my investment rate. But you might have reasons to the contrary. You might say, well, yes, my finance rate, my discount rate is 10%, but once I've gotten some return, I want to risk that. Once I own it, once it's in my hands, once it's back in my hands, I want to know I keep it, so maybe that's at a more conservative rate, right?
So is the ability to have a different reinvestment rate a factor that gives the modified rate of utility than the standard IRR?
Good question. No. Excel is simply giving you this option. What gives modified rate a greater accuracy is that it doesn't make the assumption that we're reinvesting at some rate that it is calculated. See, because until we've calculated the IRR, we don't know what it is. We don't have a means to easily see the number, right? In this case, I would have expected Excel to simply ask for the values and ask for the discount rate. And that would have been satisfactory. It's just given us some latitude a little bit greater than is necessary. But that does tell you that if you were to actually do the actual longhand equation, you put the rate in twice. So you could have it be different if you wanted it to be different. I just never do that personally. Okay? And here you can see that in this case, the internal rate of return slightly greater than the modified internal rate of return because the internal rate of return is modestly flawed. Let's look at this a little bit differently. What if I actually paid, let's say, what's the number I want? paid $544,699 for the investment. Well, not surprisingly, because that's what its present value was, right? $544,699. Not surprisingly, my net present value is almost zero. It's 42 cents. And when we're talking about $544,000, 42 cents is zero, right? We're never going to argue about it. IRR and MIRR are the exact same number. Again, not surprising to us. Okay? Okay, let's change that. What if I actually was good enough at negotiating, I only paid $100,000 for this thing? Well, now, my net present value is very large. My internal rate of return is astronomical, 92.5%. My modified rate is 75.5%, almost 76%. This helps you see the dynamic of the difference between those. When the IRR is grossly different than our discount rate, remember that was 15%, the MIRR will be meaningfully less. Okay? Any questions about that? Please.
Can you go down to the continuing value
Yeah.
and just open up the sub?
And unfortunately, you can't see some of it, so I'll go ahead and show you where it's coming from. So it's taking this value, which is the cash flow expected in time one, the year after the end of the explicit period, and it's dividing it by R minus G. Okay? Exactly as you would expect. So that's telling you that this is using a form of the free cash flow model, isn't it? It's not using the KBD model. I'm just using a cash flow of some kind. I haven't said it's free cash flow, have I? I'm just saying it's cash flow. Now, when we actually get into the firm, the cash flow we want to pay most attention to is free cash flow. But in this case, it's a little more generalized. So this setup is on Excel for you. You'll notice that I've got a whole bunch of other numbers going on down here that you may not be able to see them. They're in very light gray. But you see some numbers here. This is calculating a payback and a discounted payback. I'll talk to you a little bit more about those on Wednesday. All right? What other questions might you have?
Can you
Please.
briefly cover MIRR again and just like how it differs from IRR?
You bet. You bet. Modified internal rate of return makes the assumption that these cash flows are being reinvested at the discount rate. So it assumes that your discount rate that you've stated is the rate at which you could continually invest and make money, or to get money. It is really your discount rate, your opportunity cost of investment. Whereas internal rate of return calculates this amalgamated number by extrapolation back and forth till it hones in on something. And that calculation is assuming that the cash flows are being reinvested at the amalgamated rate, which sometimes is nutso. In a world in which my discount rate is 15%, I might be able to find some place at 95% or 92%, but I wouldn't be able to know that I could find that. That would not be a credible thing for me to assess. Maybe it happened, but every once in a while, extraordinary things happen, right? That would be an extraordinary thing. You can't count on it. It's a flaw. Okay.
Right?
I think, yeah.
It's like a really basic question, but when people say like financial models and stuff, they're literally just referring to like this, models where you're using equations based off of stuff.
Yes.
That's just like the terms of financial model, right?
Yeah, in fact, let me give you a peek into the assignment that you're going to start on Wednesday, or is due next Wednesday rather. I'm going to give you a spreadsheet, no, I'm going to give you an image of a spreadsheet that is a financial statements, income statement, balance sheet, a little bit of market information, and directly underneath it, you're going to see a whole bunch of ratios and values. Free cash flow, no plat, ROE, ROA, all kinds of stuff, market value of bonds, I mean everything we've been playing with and a whole lot more that we will play with. And you're going to be responsible, you'll have all the numbers, you'll have the image, but you won't have the equations. You know the equations are on your corporate finance quick sheet, you've learned them in Finance 300, we've been talking about them. You're going to be responsible to create or recreate in its exactness that spreadsheet. with exactly those numbers, exactly that format, exactly those solutions, exactly those items being solved for, so that yours looks exactly like mine. Then a week or so later, you're going to be given an assignment to do another one where you use those numbers to start to do some projections of some values. So you're going to end up, after I think I have 6 of those assignments spaced out over the next couple of months, you're going to end up with something such that you can, on the first worksheet of your spreadsheet model, introduce all the inputs from the cash flow, or rather from the income statement, balance sheet, and some assumptions such as growth and discount rate, etc., and it will populate the value for every one of your models. Okay, and it'll do it by going through forecasts. So we're going to build that together, and you're going to be using those to help you with the problem sets. Okay, we're modeling. All right.